Hi there, my name is Caroline Wu, and this is problem 2 of test 1. So here in the box I've written the initial conditions. It says that Dr. Greco takes a canister of compressed air to a skateboard and releases it from rest. Therefore, velocity initial is going to be 0 meters per second. There's a constant net force for about 10 seconds. And then afterwards, there's 0 net force while the skateboard is just coasting at a constant velocity for 30 seconds. The mass of the entire system is going to be 20 kilograms, right? And the problem asks, where is the skateboard going to be, like the position of it, after 40 total seconds? So we've got to split it up into 2 parts, because part 1 has a constant net force, and part 2, although it does have a constant net force, the net force is 0. All right, so here's part 1. So although the problem doesn't tell us where the skateboard starts, I'm just going to name the initial position 0, 0, 0, so origin, right? So how do we find where the position would be after 10 seconds, after that first part? We have to start from velocity. Now, I made the error, I'll show you later anyway, but we're going to find velocity final, right? And velocity initial, we've been told, is 0 meters per second because the object is released from rest. This equation is just derived from the momentum principle, where you assume that for P approximately equals mv for all like slow moving objects. All right, so velocity initial is 0. The force is given to us, as is the time and the mass of the object. So I've solved and I got V final is equal to 500 meters per second. So now I have to solve for the final position. And this again is yet another equation that's derived from the momentum principle. Position final is equal to position initial, which I've labeled as 0, plus V average times change in time. Now because the force is constant, we can use the V average as an arithmetic average. So V initial plus V final over 2. Right? Instead of V average equals V final at non-constant forces. So I've solved for V average here. Since V initial was 0, this is V final that we just solved for, divided by 2, and here is the V average times time, and that's going to give you your position after this first part, right? Okay. Here, can you see? All right. Here is part 2, where we're moving for 30 seconds, and we technically have 0 force, or a constant force, but force of 0. So we're trying to find R final, right? And I've written here R final is equal to this, because this is what we solved for here. But I'm going to go ahead and make a note that this is technically our R initial in this section. All right. The velocity during this interval is the velocity from the last interval. So I made the mistake on the test of using this velocity instead, and this is incorrect because this is the average velocity, where we combined the final velocity and the initial, right? But in actuality, we actually need this velocity final, which is 500. All right, so again, this equation appears, and we're just going to sub everything in. The initial position was the position after the constant force at 2500 meters, and then we're going to use this velocity, this velocity at 500 meters per second times an interval of 30 seconds. And I've done all the math, and it comes out to be the final position of this whole skateboard system is 175,000 meters.